Hello there. Let me get the screen set up. There we go. We have a few things to get rid of here. Sorry for the setup time. Okay, we have a very important topic to talk about here, and it's what's called overfitting. Overfitting the data. This is a big issue in any kind of machine learning environment. And let me see, I want to change my colors here. That's not going to do it. I don't know what happened to my... Okay, anyway, we can do this anyway. Let us suppose, look at this drawing here, and we imagine that we are in two space. We have some sample data points here, and here's what this all means. The big capital P's that you see here, this is training data, and these are positive examples. And these very thin script P's that you see here, these are also positive examples, but I haven't seen these. They're not part of my training data. Likewise, I come over here for the negative data and the big capital N's. These are negative instances that I have seen, and they will be used for training. The lowercase n's are ones that I haven't seen. Now, the idea of overfitting the data, or explaining this, is as follows. We've already talked about multi-layer perceptron models, so we know that we're completely capable of learning this concept right over here. And we might imagine that we might have a perceptron that is going to do something like the following. It might come over here, and it might consider all of that, and then we'll come over here, and we'll get that, and then we'll come over here, and again, I realize my lines aren't too straight. We'll get that, and maybe we'll have another one over here that'll do that, and then we'll have another one over here that'll do that. So I would have these 5 different perceptrons here, okay, and we can see we would point this way, we'd point this way, we'd point in, we'd point in, we'd point in, and we could AND these all together. And this is a pretty nice representation here. This would seem to capture all of our positive ones, and the positive ones are appearing inside this region here, and the negative ones are outside. But let's consider another situation. So here is the same drawing again. And let's suppose I came over here, and I might have one perceptron that's going to come over here, and it's going to learn that. And then I might have another one that's going to come up here and do that. And I could have another one over here that's going to do that, and another one there that's going to do that. And then maybe I could do one that's going to come down here like this, and I could have another one that's going to come over here and do that. And I think you can all see the point here. Like that. Now, of course, when I've drawn these short lines here, the interpretation here is that these are extending this way, but it's going inside. But you can see that what you can see when we compare this one to this one over here, that is not the correct model. When we had the previous one, I believe we had a total of 5 different perceptrons that got us our bounded region. And what those 5 perceptrons did is they also included these unseen positive examples. Over here, you can see that it's going to take 1, 2, 3, 4, 5, 6, 7, 8 perceptrons. But what we've done here is we have exactly fitted these perceptrons to fit the observed data that we've seen. The problem that we have here is that when we put all of these together, this is not going to generalize well to the data that we haven't seen. Specifically, if we were to have this particular model right here and then feed it this particular P right here, it would say, well, that's a negative example. Or if we were to feed it this particular P right here, it would say that that's a negative example. Any of these ones falling outside of that region. And the problem that what we have done here is we have overfit the data, okay? And overfit the data comes about because we actually had too many neurons, okay? Too many perceptrons. And by doing that, we were able to create a contour just around all of the observed positive examples, and it did not generalize well to the positive examples that we hadn't seen. Let's see if we can go back to the other example that I had here. Yes, this one right here. See, over here we had less neurons, okay, and we managed to get them so that we were capturing some of the positive examples that we hadn't seen. This raises a very interesting research question when it comes to neural networks, okay? Typically, the neural network scientist is given a bunch of data, and there are a couple of things that they don't know. The first question is, how many neurons do we need? And in general, we don't know the answer to that. This is where people who work with a lot of neural networks, where they have to do a lot of experimenting and look at the results. You specify too many, and you are going to overfit the data, and your model will not generalize very well to data that you haven't seen. If you specify too few neurons, okay, it's not going to be very accurate. And then the other big question, what is the topology? Okay, now topology is a big word, but it's not that complicated. You may recall when we discussed the neural network model, the final one, we said, well, there's a whole bunch of inputs. That there was the input layer, there was the hidden layer, and then there was output. And we indicated that this thing over here, that this was really, and you could think of this as implementing logical and you could think of this thing over here as implementing logical or. But now the question is we really don't know how these things should be connected. Should there be a connection from this neuron to this one? Should there be a connection from this one to that one? In other words, how do the connections between this layer and this layer, what do they look like? And that's what's called the topology. And it's never really clear exactly how that should be done either. And there are lots of research papers out there and heuristics out there about taking some guesses. But again, the idea is that you don't just put a neural network together and it works. There's a lot of experimenting that has to be done. Okay, that's the end of this video. Very simple concepts here, but very, very important ones.